In this activity, I'll demonstrate a complete home automation system I built. It integrates an Arduino for sensor reading and device control, a Python backend for data processing and storage, and a web-based dashboard for real-time monitoring and interaction. The system starts with the Arduino, which is connected to a DHT11 sensor to read temperature and humidity, and LEDs for visual feedback. This code sets everything up and runs a continuous loop. Every 2 seconds, it sends sensor data over the serial port in a simple format, which is temperature, humidity, and the current status of the main LED. It also listens for commands with 1 to turn the LED on or 0 to turn it off, allowing for remote control from the computer. The backend is built with Python. First, the out.py handles user login by checking credentials against a local JSON file. The database manages our MongoDB connection, inserting new sensor readings and fetching the latest data for the dashboard. And finally, the serial reader.py is the communication bridge. It opens a serial connection to the Arduino, reads the incoming data in a separate thread, and stores each reading in the database. It also sends user commands from the dashboard back to the Arduino. Now, after I start the MongoDB and run the application, as you can see, the system is secure, starting with a login page. I log in using the demo credentials. Once authenticated, we see the main dashboard. At the top, you can see a logout button. The dashboard has 2 main sections. First, the LED control panel. Let me click turn on. As you can see, the yellow LED turns on when I click the turn on button. And when I click turn off button, it turns off. This sends the character 1 through the backend serial module to the Arduino, which turns on the connected LED and confirms the action. The second section displays real-time temperature and humidity data, fetched from the latest record in the MongoDB database. The system also shows the connection status of the database here. The dashboard automatically refreshes every couple of seconds to show updated readings. You also notice an automated feature on the Arduino. A red LED lights if the temperature is 21 degrees Celsius or above, and a green LED lights if it's below. This is a simple example of rule-based automation running directly on the microcontroller. The reflection of this activity is that The reflection of this activity or final project is that this home automation project was an immensely valuable exercise in integrating hardware, back-end logic, and user interface into a cohesive full-track IoT system. It deepened my understanding of real-time serial communication as I had to manage continuous data flow between the Arduino and Python backend without bottlenecks or conflicts. Building the secure login system and dashboard with Streamlit taught me about session state management and creating intuitive user controls. While implementing the MongoDB layer reinforced the importance of structured data persistence for sensor logs. Most significantly, I learned to troubleshoot the entire data pipeline, from ensuring the Arduino sent correctly formatted strings to debugging thread-safe operations in the serial reader, which highlighted how critical robust error handling and modular design are in creating a reliable end-to-end application that bridges the physical and digital worlds.